Hi, welcome back to another episode of Python Programming from Beginner to Programmer. In today's session, we like to discuss a very fundamental yet very, very important aspect of programming that's got to do with the very golden asset that we speak about these days, that is data. So, the very property about data that concerns us today is data type. Now, we will split that discussion into three main topics: scalars, composites, and structured. Right? Scalars, composites, and structures are all supported by Python. Scalars basically are indigenous, basic, atomic data type that cannot be broken down further. All right, so they are the primary building blocks of other higher level data types. So there are four scalar data types in Python: Boolean, integer, floating point data type, and also string data type. Then we have composites, which are basically structures that can contain scalars as well as other composites. So again, there are four composite data types supported by Python, namely list, tuple, set, and dictionary. Finally, there is also a built-in mechanism for Python to support other structures that users, programmers like us, uh, can imagine, right? So if we want to construct other data types, we can. So we can make use of Python's class mechanism to construct any kinds of structured data types that we want, and yet Python doesn't on its own support, right? So we can do all these. Let's begin with our discussion on scalar data types. As we started off describing, there are four scalar types, meaning atomic types. They are the most basic, indivisible data type that Python supports. So what are they? They are Boolean, integer, floating point, and string. So these four data types are separately described by the four keywords: int, float, bool, and string. Now, it is important to understand that these types, in fact, any Python data type, whether it is scalar, composite, or structured, they are describing the behavior of the values. Remember the assignment statement, variable equals to value? We're talking about the right-hand side value, right? The value has data type. In Python, variables, you can sort of say that it doesn't have any data type because Python allows us to store any value into the container called that name, the variable name. So the container itself is not selective. It doesn't quite distinguish whether the value being stored is matching its own container. I mean, just imagine your day-to-day container. We will put on a label, and that we already understood as the variable name, right? So we say that container is called X. So we'll say put this value number 3, or this ball labeled with number 3, put inside that container called X, and we know exactly what to do, which means Python knows exactly what to do. That's fine. Now, what happens if we are very strict about it? We are saying, this container, it's called X. But you know what? I don't allow you to put anything except just balls. All right, so only balls can be put inside the container. Now, if that's the case, then if you have a book, you will not be able to put inside the container called X, even though it is empty, right? So that is called typing the variable. So the variable, the container itself has a type. It doesn't, or it's not allowed to hold any value, any items that is not the same as the type of items that it was designed to store, right? So Python is not like that, right? Programming languages like Java, C, C++, they are very strict. Containers must have certain type, designated type, and the values will always have its designated type. So they must match before you can store. And that makes programming rather challenging, because a programmer must always make sure that the declared data type of a variable, the container, must match the data type of the value that is being stored inside. And if they don't match, the programming language like Java, C, C++ will stop you right there. You cannot even run it. Fortunately, Python is very, well, you can say it is laissez-faire, it is very understanding, it is very generous, whatever. It doesn't require you to declare or enforce the container to hold any particular type. So the container may hold anything: book, balls, baskets, all the items starting with B, right? Anything at all you can put inside. But the data that you put inside, the item that you put inside the container itself, will have some sort of a categorical description, right? So a book may be labeled book number 1, book number 2, but it's a book. It's a book. And it is not a ball, for example. So if a book is called integer, then only integers can be put inside this container, right? So then we will say this book has the type integer. So I'm just trying to equate book as integer. But of course, Python will understand it as int and not book. So just like we may be a bit fussy, we may say that, write the 3 on book, not scribble it on a ball. And if we do that, then this 3 has got a particular category, right? Because it is a book now, a book with a label 3. So we put it there. And we might also write 3 on a ball, and it becomes a bit curved because of the round spherical nature of the ball. And we try to write it as neatly as possible. This 3 has got this notion called 3. The meaning is 3, but it is now stored, or has this category called ball, right? And likewise, in Python, that feels like the difference between writing a 3 on a book and writing a 3 on a ball. That difference feels exactly like having an integer value called 3 and having a floating point value called 3.0. Both gave us the notion of 3, right? 3 something, the quantity of 3. But they are represented with different data type. And now you're beginning to get a sense that, integer 3 is not really the same as 3.0, because scientifically 3.0 means I know that it is exactly 3 to the first decimal place, but second, third decimal place, I don't know. I'm not very sure. But integer 3 is definitely confirmed to be just 3. It will not have any integer at all, right? So these are the fine differences that Python enforces on the data values that we must therefore also observe for good reasons. For example, in cryptography, we operate a lot on integers, or at least modern cryptography. And in visualization, simulation, and many different sorts of calculations, we rely a lot on floating point calculations. And so those data will be basically float. Even if they accidentally happen to be just 3.0, that's still a floating point notion of 3. Yeah. So we do distinguish very carefully between the two. And more importantly, because Python does distinguish very carefully and very strictly between different data types. For example, it is problematic if you try to add a true or false in Boolean data type to a floating point 3.1. What does that mean, right? You're adding a true to 3.1. What does that mean? There is no meaning unless we kind of give it some sort of a rounded meaning, like true means 1, and so 1 plus 3.1 means 4.1. But that is not safe, because it's our own very subjective definition of what adding Boolean to float means, right? So it's not safe, it's not internationally recognized, it's not supported by fundamental mathematics. Now, int and float, they are so commonly used in that Python does allow for some sort of abuse, where we start adding 3 to 5.1. That is allowed, all right? But adding a string like hello to 5.1 is undefined. I don't know what it means. If you can figure it out, you know what it means, and nobody else in the world knows, right? So because of that, we tend, or at least Python will not allow mixed data type operations, right? So like I started introducing the notion of data type. Data type itself dictates how the operation uh, will proceed. And if it cannot come up with a meaningful operation, for example, 3 plus 5, and that's 8, that's meaningful. But 3 plus hello, that is not meaningful. So if that's the case, then Python will just stop right there and say error, cannot continue. So let's sort of look at how we can represent data and what they mean in Python. In Python, we can enter values like these. So this is an integer 5. Integer 5. And of course, uh, it's probably not as astounding as I seem to be so excited about. But the idea is it is a manifest type data. What does that mean? It means that when I type it out, you know that the data type is 5. It's integer. It's not floating point. How come? Because the next value that I type is 3.45, and that is definitely a floating point. How do I know? Because there's a full stop here. There's a dot. There's a decimal place here. So if I had wanted 5 to be a floating point data type within Python, I should have typed something like 5.0 or even just 5 point. The presence of a point tells Python that yes, the value is 5, but it's not an integer 5. Don't store it as integer 5. It is to be stored as floating point 5. So all these are literals, as we learned last time. They are values that we can explicitly type into Python. That might not sound as surprising, but all other values are actually derivations derived from some other values that have been previously typed in, or else they are read in from database that has been typed in by somebody else, or else they are read in from Excel files or text files that have been typed in by somebody else. So all the data that Python can produce, can generate, must have been derived from some combinations of existing literals or else derived data from somewhere else. So that's why it is a bit astounding in that sense. Wow, all data that Python can compute originally comes from typing it in somewhere, sometime before. So this is manifest type literal, because we can tell the data type literally from looking at the constant itself, the literal string itself. So we have an integer here, floating point here, a boolean here, because false and true, they are reserved by Python to mean the explicit notion of true and false in Boolean sense. And then we have a string that we sort of briefly touched on in previous video session. That even though it contains the digit numbers, they are not number per se. So the string 987 cannot be compared with the integer 987. It doesn't quite make sense. So let's just run it and see what